कि हमको वेरिएबिलिटी डिटरमाइन करना है, वो वेरिएबिलिटी इफेक्ट कर रहा है ट्रीटमेंट आउटकम को कि नहीं। और ऑन प्रिंसिपल एनोवा इज कैलकुलेटेड बाय द रेशियो ऑफ द एफ रेशियो, एंड एफ रेशियो इज डिपेंड ऑन द रेशियो ऑफ वेरिएबिलिटी of the different components, and the ANOVA is divided into 3 types on the basis of the research design. इसका आधार क्या है? Research design. First, the single factor independent measure ANOVA. First क्या है? Single factor. Factor क्या होना चाहिए? 1. Factor का मतलब treatment factor. The factor which we use for the treatment is 1. An independent measure. That means the independent sample is collected from the different populations. ठीक है? And collectively, if we analyze the effect of treatment, मतलब factor, single factor, on the different populations, samples derived from the different populations, it is referred as single factor independent measure ANOVA. इसको हम क्या बोलेंगे? Single factor independent measure ANOVA. Here the single factor repeated measure ANOVA. क्या बोल रहा है? Single factor is 1, but sample is
repeated.
Same sample is used for the repeated treatment. That means it is responsible for the analysis of exposure time. जैसे अभी हम बोले आप लोग ये आकर ये क्या बोल रहे हैं? कोरेक्स पी रहा है। अब मान लीजिए कोई लड़का एक है, वो 1 महीने तक कोरेक्स पिया, उसका इफेक्ट देखें। उसी लड़के का 2 महीने के बाद इफेक्ट देखे, उसी लड़के का 4 महीने के बाद इफेक्ट देखे, उसी लड़के का 1 साल के बाद इफेक्ट देखे। तो यहां पे क्या है? सैंपल इज सेम, फैक्टर इज सेम, बट द सैंपल इज ऑब्जर्व ऑन द सेम फैक्टर, इफेक्ट ऑफ द सेम ट्रीटमेंट ऑन द टाइम गैप, एक टाइम गैप पर रिपीटेड कर रहे हैं। तो ऐसा अगर बहुत सारे बातें होते हैं, इम्यूनोलॉजिकल आप स्टडी कर रहे हैं, कोई एक्सपोजर टाइम का स्टडी कर रहे हैं, सिगरेट पीने का स्टडी कर रहे हैं कि सिगरेट पीने का इफेक्ट लंग्स कैंसर के डेवलपमेंट में क्या हो रहा है। तो कोई 1 वर्ष तक पिया, कोई 5 वर्ष तक पिया, कोई 7 वर्ष तक पिया, सेम पर्सन, पर उसके लंग्स का इफेक्ट क्या हो रहा है, उसके लंग्स का इफेक्ट क्या हो रहा है। तो दैट इज एक्सपोजर टाइम। दैट मीन्स वी कैन एनालाइज द एक्सपोजर टाइम। अगर हम कोई एक्सपोजर टाइम को स्टडी कर रहे हैं तब उसको क्या बोलेंगे? सिंगल फैक्टर रिपीटेड मेजर ANOVA. Third one is the 2-factor independent measure ANOVA. यहाँ पे क्या है? 2-factor independent measure ANOVA. And here the research designing quote लेता है जी। Here the research designing is based on the 2-factor, मतलब 2 factor, 2 independent simultaneous factor, 2 independent simultaneously effect treatment of the 2 factors used simultaneously on the independent measure ANOVA. That means the sample is collected from the 2 or more than 2 populations, but we study the independent treatment effect simultaneously for the 2 factors, 2 factor. For example, suppose हम जैसे उसको कल बोले थे कि तुम आयरन का इफेक्ट देखो प्रेग्नेंट हो गए। अब मान लो कि हम ट्रीटमेंट ऑफ आयरन टैबलेट देख रहे हैं, ठीक है, ट्रीटमेंट ऑफ आयरन टैबलेट, और 2 फैक्टर, एक तो आयरन टैबलेट का हीमोग्लोबिन पे इफेक्ट देख रहे हैं, और वहीं पर हम पॉपुलेशन को बांट दें कि पुअर और इकोनॉमिकली वेल टू डू। तो यहाँ पे पॉपुलेशन जो 2 भाग में बढ़ गया, तुरंत पॉपुलेशन जो है वो 2 भाग में बढ़ गया, लेकिन पॉपुलेशन फैक्टर क्या हो गया? 2 फैक्टर कौन सा हो गया? एक इकोनॉमिक और दूसरा आयरन टैबलेट। अब यहाँ पे जो हम स्टडी करेंगे, तो यहाँ पे स्टडी क्या होगा? 3 इसके हाइपोथेसिस डिराइव हो जाएंगे। इसके हाइपोथेसिस कितने डिराइव हो जाएंगे? 3। पहला factor 1 has no effect, दूसरा factor 2 has no effect, तीसरा factor both factors are integrated or not, मैंने दोनों मिल के काम कर रहा है कि नहीं कर रहा. That means the ANOVA, single factor independent measure ANOVA, single factor dependent measure ANOVA और two factor independent measure ANOVA are responsible or analyzed on the basis of the research design. On the basis of the research design. ठीक है? I was discussing my last class. And here one illustration is represented. That we use a factor that is vitamin D for the treatment of the rickets. ठीक है? And we observe the disappearance, day of disappearance of the deficiency characters. ठीक है? We selected 3 samples and 1 placebo. And the date for the disappearance of characters is observed as here in one population, one sample in the 8th day, in second day, 4th day, 3rd day, and 3rd day. In second sample, 2nd day, 4th day, 1st day, and 3rd day. In third sample, 3rd day, 2nd day, 5th day, and 6th day. And now, before the initiation of the calculation, we simplify the findings. At first, we will calculate the total of the xi for each sample. The treatment number is 4. J is 4. That is total value of the xi. The second one is the total value of xi square for each sample. Third one is the mean of the each sample. Fourth one is the mean deviation square of the each score for each sample. Second one, the n value. Now, the n value of j samples, j values, j samples, all samples, that is n1 plus n2 plus n3 plus 1 n4, that is 60. Sometimes we observe the unequal number of samples also. It is the equal, यहाँ पे 4 4 4 4 है, but it is not necessary. Sometimes we have constraint and we are not in a position to provide the equal number. कभी कभी ऐसी भी समस्याएं होती हैं कि हम तो काम कर रहे हैं, सिंगल फैक्टर पे ही काम कर रहे हैं, इंडिपेंडेंट मेजर ANOVA पे काम कर रहे हैं, लेकिन वो इक्वल नहीं होता. तो वो इक्वल नहीं होता, उसमें घबराना नहीं है. That you don't multiply by the n4 into 4. You calculate the independently for the total score and for all these scores. Now, in the last class, we calculated the 2 values. We have 2 values. We want 2 values for the calculation of F ratio, that is MS between divided by MS within. And then for the calculation of the MS, मतलब mean sum, variance. We want the mean deviation, fractional mean deviation and respective degree of freedom. Clear? And for the SST, sum square of total, we calculate the value by calculating the total sum of x square, total sum of x square of the total sample, minus total sum square of the total samples divided by n. Then we calculate this value at the 407. It represents the sum square of total. Then we observe the SSW, sum squares of within, and here it is sum of the total sum of the mean deviation square of the total sample. That means the 66. The value is the 66. And now then we observe the SSB by simply subtracting the value of the SSW from the SST. And here the value is 341. Of course, we have also the independent formula for the calculation of SSB. But here I am not using that formula, and just I am going to use that in the single factor lifted measure. आगे हम इसको कर रहे हैं. And then we calculate the degree of freedom. That is degree of freedom of the total is equal to n minus 1. That is 50. That is degree of freedom of B, K minus 1, that is 3. And degree of freedom within, that is n minus K, that is 12. And after the calculation of sum of a square, we want to calculate the variance. But in the F test, the variance is calculated in the form of MS. In the form of MS, that is mean square. Of course, it is variance. But the term used here, the mean square. The mean square T is equal to SST by VT. That is degree of freedom of total. That is that calculated is 27.13. Then mean squares of the W, that is SSW divided by degree of freedom of W within. That value is 5.5. And then MSW MSB, sorry. MSB, that is SSB divided by degree of freedom of the between. That is 113.6. And after the calculation of the MST, MSW and MSB, we calculated the F value. That F value is calculated by MS between divided by MSW. That is 20.6. And here we observe the table value of the F at the degree of freedom between 3 and within 12 is 3.49. It is the table value. That is the critical value. And here the calculated value is 20.6. That means the null hypothesis that all the population means are equal is rejected. And the rejection of the null hypothesis in this condition suggested that the medicine of the vitamin D, medicine of vitamin D is useful for the treatment of rickets. ठीक है? इसमें कहीं दिक्कत किसी को? Anyone?